This is part 1 of the Chapter 11 review, beginning with problem 1. In problem 1, we're asked to find the diameter of circle P, and we're given the circumference. The diameter is given by the circumference. Circumference is pi d. It's 2 pi r or pi d. And so let's go ahead and put that relationship down and see where it leads us. So for problem 1, we know that circumference is pi d, and we're looking for the diameter. So all we really have to do is divide by pi. So let's substitute in our 94.24 and divide by pi. And that gives us our diameter. Put that in our calculator, and that gives us a diameter of 29.998, which is approximately equal to 30. Alright, let's move on to problem 2. Problem 2 is a little bit different. It gives us an arc length. We have an arc length here of 5.5 centimeters and a central angle that sweeps out that arc of 35 degrees. Now remember that our relationship for arc length is to circumference as central angle is to 360. Now substituting in what we know from the problem statement, we know the arc length is 5.5, and we divide that by circumference, which is what we're looking for in this problem, circumference of circle F, equals the central angle. The central angle they gave us was 35 degrees over 360. Now, we have to do a little manipulation here, and I'm going to multiply both sides by 360. So 360 times 5.5 over C equals 35. Now, I'm going to multiply both sides by C because I have to get the C out of the denominator. So let's move up to here, and we have 360 times 5.5 equals 35C. Now to solve for C, it's all I need to do is divide by 35. 360 times 5.5 divided by 35 equals C. Put that in our calculator, and we get about 56.57 is about equal to C. Alright, let's move on to problem 3, and I'll erase the board. Problem 3 is a little bit different still. We're given a central angle of 115 degrees and a radius of 13 inches. We're looking for the arc length now of AB. So let's go ahead and write down our information, see what we have. We know that arc length is to circumference as central angle is to 360. We always write the same relationship down when we're dealing with arc length. We are given a radius and a central angle. So arc length is to, well, circumference is 2 pi r. So we can write 2 pi times 13, which is our r, equals the central angle, 115 over 360. Now, that's all we really have to do is multiply by the circumference here. So arc length is 2 pi 13 times 115 over 360. Now, I usually do calculations like this because it's much easier, for me anyway, to put in the calculation once, and I avoid making a lot of silly mistakes by transposing letters or numbers when I'm writing things down. So let's go ahead and put that in our calculator, and we get about 26.09. Just as a side note here, you'll want to use the pi key on your calculator whenever possible. Unless you're told otherwise, don't use an approximation such as 3.14 because you're going to lose some precision. Most of the time your results are going to come out very similar, but there will be cases where you will see problems that have answer choices that are very, very close, but you always want to be as precise as possible. Use the tools at hand. In the days when we just had slide rules, didn't have much choice, usually went out to 3 or 4 decimal places, but in this case we have calculators, so use the calculator and you'll be safe. Alright, let's move on to problem 4. In problem 4, we're given a situation. We have a mountain bike tire has a diameter of 26 inches. To the nearest foot, how far does the tire travel when it makes 32 revolutions? Well, I have to draw some pictures because I need to see what's going on here and get a little visual representation. So let's try to draw a tire in here. Alright, now if I have this tire and I'm going some distance with the tire, I want to see how far the tire rotates, how far the tire moves when it rotates. Well, what that's talking about, it's talking about the circumference of the tire, and we're looking for 32 revolutions. So if we say that we need 32 revolutions, and we know that the diameter is 26, so let's just put a diameter in here, or something that's approximating a diameter. And we get 26 inches. We're going to be looking for circumference. So circumference is pi times diameter, which is going to be 26 times pi. And we're looking for how far it goes in 32 revolutions. Well, if the circumference is how far it goes in 1 revolution, then we just multiply this value by 32. So the distance is given by circumference times 32, which is going to be 26 pi times 32 revolutions. And that's going to be approximately 13.8 inches. Now, it was asking us to the nearest foot. We got inches, so we're going to have to convert this to feet. So we divide the inches by 12, and we get approximately 217.8, and they wanted it rounded to the nearest foot, so that's about 218 feet. Alright, let's move on to problem 5. In problem 5, we're moving on from length to area. So here we're looking for the area of this sector. It sweeps out an angle of 240 degrees, and the circle has a radius of 9. Let's go ahead and write down our formula for area of a sector. So for number 5, area of a sector is to area of a circle as central angle is to 360. Very, very similar to arc length. In the arc length formula, we had arc length is to circumference, and the whole idea is part to whole, part to whole. So this is part of the area to the whole area is part of the angle to the entire number of degrees in the circle. So part to whole, area, area, angle, angle. Let's go ahead and put in what we know. We're looking for the area of the sector. Our area of a circle is going to be pi r squared. So the area of the circle is pi 9 squared. The central angle is 240 degrees, and that's divided by 360. Now all we need to do is multiply by the area of the circle here, and we have area of the sector is pi 99 squared times 240 divided by 360. We go ahead and put that in our calculator, and we get approximately 169.65. So very, very similar to arc length, just a few little differences. Now there's another way to do this that takes a bit more energy, but you could find the area of the circle and then subtract off this area of the sector here. But that's a much more indirect way, and you'd have to calculate this central angle, subtracting this from 360, and it's a lot more energy, but it's still a way you can do it. So do whatever way you think is best for you, but I like the more direct approach. All right, let's move on to problem 6. Here we have a rectangle, and they have this little circular shape cut out of the rectangle. Now let's analyze this just a bit. We're looking for the shaded region here, so we have to cut this thing out. We first have to figure out what this is. Well, if this is the center of a circle, then clearly this indicates that these are radii, so this is a diameter. That means this has to be a semicircle. So this gives us half of a circle. So what we would want to do then, it's kind of like taking a cookie cutter, and we're taking half of a circle out of this rectangle. Working this problem out, we'll have the area of the rectangle, which is minus the area of the circle divided by 2, because it's half the circle. So the area of our rectangle is 6 times 4, it's just length times width, minus the area of the circle. Well, the area of the circle is going to be pi times radius squared. If this side length is 4 and the diameter is 2 times the radius, then we know the radius has to be 2. So the area of the circle is pi 2 squared, because 2 is our radius, divided by 2. Now that's all we have to do is put this in our calculator. We get the area of the shaded region is about 17.12. No, that's 17.72. That takes care of problem 6, and we'll start problem 7 in the next video. So I'll talk to you in the next part.